Now let's start with the easier way to understand which is the reduction agent and which is the oxidizing agent is by the oxidation number. The oxidation number is the simple way we can assign it to each element in a neutral compound or charged entity. Let's start with the oxidation number. That the oxidation number is the charge of the atom that would have in a molecule or an ionic compound if electrons were completely transferred. Some rule that you have to memorize about. First, every free element, which means that free element is uncombined state, have an oxidation number of 0. I have natrium, this is free element, beryllium, kalium, potassium, and then this is the lead, hydrogen, oxygen, and phosphor. All of these free elements, the oxidation number is equal to 0. Second one, if you found the monoatomic ion, so the oxidation number is equal to the charge on the ion. Here the Li plus or the lithium plus, which means that the lithium have the oxidation number is +1. It's the same with the charge of an ion. When I have the Fe3 plus, so it will have the Fe, the oxidation is +3, oxygen 2 minus, so the oxidation number is -2. The third one, always remember that the oxidation number of oxygen is usually, please note it that it is usually -2, except in, it is only except in the hydrogen peroxide, in which the oxidation number of the oxygen is equal to -1. Fourth one, the oxidation number of hydrogen is +1, except when it's bound to metals in binary compounds. In this case, the oxidation number is -1. Fifth, let's see here that the group 1A metals are always +1. 2E metals are +2, and fluorine is always -1. To understand about the oxidation number, that you have to understand in each neutral molecule or an ion, the total charge, the total oxidation number of every element in the molecule on an ion will the same with the charge of the molecule or an ion. Oxidation numbers do not have to be integers, and oxidation number of oxygen is the superperoxide ion. For the superperoxide ion is -half. Now let's see. From the 7 rule of the oxidation number, let's start to identify the oxidation number of each element in the molecule. For example, I have a question here. What are the oxidation number of all the elements in HCO3-? Okay, if you see this one, what do you think? Is it a molecule or an ion? Exactly. Because it has the symbol -1 here, so it must be an ion, in which we revert to the number 6 rule, that the sum of oxidation number is equal to the charge of the ion. Now let's see here that I have in this molecule, I have 1, 2, and 3 elements. So because I have 3 elements, I have to identify 3 oxidation number of 3 elements that in this ion. Now let's see. Refer to the number 6. So the total number of oxidation number of hydrogen, carbon, and oxygen. And please note that the third one, this is, you have 3 here after oxygen, so it means that the oxygen contained in this molecule is 3. So it means that the total oxidation number of hydrogen plus total oxidation number of carbon plus 3 times oxygen oxidation number is equal to -1. Start here, we have here that the oxygen is always -2, and then the hydrogen is always +1. Determine what is the oxidation number of the carbon. 3 times the oxidation number of oxygen +1 plus the oxidation number of the carbon, because the carbon only 1, so we only put it 1 number, yeah, the one value here is equal to the -1. The -1, as mentioned before, that this is the charge of the ion. So what we got here, that the carbon will have the oxidation number is +4. The oxidation number of an element in their compounds, maybe we can see in the periodic table as the role of the oxidation number, that for the group 1A is equal with +1, except the hydrogen, which will be in the exception. And then for the 2A is +2, and for the fluorine is only -1. While all of these components, yeah, all of the element beside the mentioned before, is sometimes we have to found it by self. As you can see that for the B group, they may have the oxidation number more than one oxidation number. That's why when we found the oxygen number, yeah, in the molecule, we may identify them by following the rule before, such as the carbon, yeah, carbon. We can see here that it may have +4, +2, or even -4, depend to the molecule.